So for those of you just coming in, final exam information is up on WeChat. Both your previous year's finals for the past 4 years and your study guide. On course sites, if you go to final exam resources, you can also find diagnostic tests. There's diagnostic tests for all of the major topics that are on the exam. They will automatically be scored after you finish. There's about anywhere from 6 to 10 questions on each topic. So I'd actually start there. After you hit submit, instead of just telling you, here's your percentage score, it also goes back and gives you the step-by-step solution guides, kind of like we've had for some of the previous tests this year. So that's a good way to get started. I would take that, get your percentages, figure out what your strengths and weaknesses are, go over all of the review that it gives you for your weaknesses, and then go to some of the previous year's final exams. Take the previous year's final exams for the sections that you didn't score so well on the diagnostic test. Then check against the answer key, and you can use that to study. Again, about 4 weeks left. Okay, so for today, I'm going to go over one more shell method problem. And once we finish our additional shell method problem, I'll release you guys so you can go ahead and work on your quizzes. Okay, so I've got 4 people with us right now. Jana, Aileen, and Kelly, I see. I guess the 4th is me. So I'm going to start with Jana. For number 10, would you use dis method or shell method for this?
Shell method.
Okay, we are going to use shell method. How do you know that we need to use shell method here?
The axis is vertical.
The axis is vertical, perfect. Okay, so I'm going to zoom in here. Oh. So if we draw, I'm going to make a line here so that we have our height and an infinitely small dx. And we're going to spin that around our axis of rotation. 2, 3, 4, somewhere out here. Okay, so here in yellow is the circumference that we'll be building. It can also represent, if you look at it from edge to edge, our infinitely small dx. We've created a paper-thin, toilet roll-shaped cylinder with a hole in it. That also has a height here in red. And a radius, which I'll draw in green in a minute. Okay, so while I'm drawing, I'm going to jump down to Aileen next. Aileen, what would the height be for this cylinder? Let me zoom out a bit so we can get our equations too.
One minus 3 root x.
Okay, 1 minus the cubed root of x is perfect. Your height is always your difference in the two y values. I'm going to label this as y2 and y1 since this is my larger y. So our height is y2 minus y1 or 1 minus the cubed root of x. Perfect. Down to Kelly next. Kelly, what is the radius here in green?
X plus 4.
Okay, x plus 4. Okay, our radius is always our rightmost x value minus leftmost x value. In this case, our axis is on the left of the x value, so this is our x value minus the axis. So if you think of your height as a change in y, then your radius is a change in x between your axis of rotation and where you are right now. Okay, and the last thing we need is depth, which is our infinitely small dx and doesn't change. So if I was to cut this cylinder, okay, not a good coloring job. If I was to cut this cylinder such that we had something like this, then we could unfurl it into a rectangle. Which would look something like this. With our infinitely small dx on top that formed our yellow circumference. And height. I guess we can make this side yellow too. So we've got our infinitely small dx, our height, and our distance. All the way around this cylinder would be 2 pi r, or our circumference. Okay, Sarah, so let's go ahead and set up our volume equation then. What would our volume be equal to?
2 pi. 1 and 0.
Okay, 2 pi, and we're going to integrate from 0 to 1.
And 1 minus 3 root x
Okay, 1 minus the cubed root of x.
multiply x plus 4.
Okay, times x.
And
Perfect. Times x plus 4 times dx. Okay. So the last thing we need is just to simplify this, and then we can integrate. I'm going to jump over to Gianna next. Oh wait, do I have someone added? No. Okay, so Jenna next. What happens when we distribute?
X plus 4 minus cube root of x times x
Okay.
minus 4. Yeah. Times cube root of x.
Okay. The cubed root of x is x to the 1/3 power. So what will happen when I multiply x to the first power times x to the 1/3 power?
What? Can you repeat the question?
Yep. For this term here, this I want to rewrite this into a form that we can use with power rule. So if I'm multiplying x to the 1/3 power times x to the first power, what will I be left with?
X to the 4/3
X to the
power.
4/3 power. Perfect. So this is really, if I want to write from order of least to greatest, x to the 4/3 plus x minus 4x to the 1/3 power plus 4x to the 0 power, which we don't have to write. Okay, all times dx. Okay, I'm going to jump to Aileen. Aileen, what will happen when we integrate?
2 pi times x to the 7/3 over 7/3 plus x squared minus 4x to the 4/3 power over 4/3 plus
Okay. I'm kind of skipping a step here, so I guess I'm going to go back and write that. Dividing by 7/3. Okay, got 2 terms left.
x squared and 4x
X squared.
over 2.
Okay, and 4x. Cool. If I'm dividing by a fraction, we can flip and multiply. So what should these be?
Um, 3x to the 7/3 divided by 7 plus x squared over 2 plus 12x
Okay.
to the 4/3 power over 4
Okay. And I'm going to
plus
go.
4.
That's 4x. I'm going to go ahead and simplify this one too. So when I flip and multiply, this will be 3 over 4 times 4, and the 4's will cancel, so this will be left with 3. Okay, and I'm ready to plug in. So I'm going to jump down to Kelly. What happens when we plug in upper bound minus lower bound?
It's 3 over 7 plus 1/2 plus 3 plus 4 minus 0.
Okay. So I distributed the 2 pi to both the upper bound and the lower bound, but because we're multiplying by 0, we're not going to worry about it. Let's see, I don't really want to run off the page, so I'm going to go ahead and draw a squiggly line and keep going over here. What happens when I add this together? 3/7 plus 1/2 plus 3 plus 4. Or what's our common denominator that we could use?
14.
14. Okay, so let's go ahead and change everything to 14s.
6 over 14 plus 7 over 14
Okay, and then 3 and 4 is 7. So
plus 7 multiplied by 14 over 14.
okay. So if we add state across, I've got this. What will happen? Oh, hold on. Actually, I've got a sign mistake. All the way back over here. Two of these signs are negative, and I didn't carry them right. Okay, so I've got to go back. That's both of the ones that had both the ones that had a fractional exponent are actually negative. I'm so sorry. Okay, so this is negative. And that leaves us with negative 3 plus 4 is 1. Okay, that does make our math easier, but sorry about that. What's going to happen when we add straight across?
It's 15 over 14.
Okay, and if we simplify?
15 pi over 7.
That's good. Okay, a little bit of a mistake with my carrying signs from one step to the other, but any questions on what we did here?
No.
Okay, so I've kind of really slowed down for this unit and give us a lot of time for a disk and shell method. So I can see most of you guys are already doing great on the homework, but we've got the quiz problems that are due Thursday at midnight. It's a mix of shell method problems, disk method problems, and volume by cross-section problems. You can use your notes, you can use previous problems. There's lots of video guides on YouTube now that we've been recording together. So please try to get by midnight, and I will see you guys on Thursday with the review lesson on probability for the final exam. Okay, thank you guys for coming.
Bye-bye.
Goodbye.